In this episode, we will look into what is a data model in iOS app and also how state binding can be used for data model. An app design is composed of user interface and data model. User interface is composed of views and view hierarchy that is shown to the user. A user can read the data and write the data using this user interface. Data model is the representation of data that is used by app. It's a custom type defined by the app developer. In the diagram here, circle, pentagon and square represent the three sources of truth, and these pieces of data are used by different views in the user interface. A change in one piece of data in data model should reflect in the different views which are using it to be updated and rendered with those changes. These changes in data should be reflected in the views which are depending upon this data or reading them. SwiftUI framework provides certain tools to allow such observation and such connection of data. Tools that the framework provides are mostly the property wrapper types, and these are state, observable, binding, environment, and the other which are listed here in the diagram. The diagram here represents how a change in data 1 to data A in data model is observed in the user interface, and the updated views are re-rendered. The property wrappers which are leveraged are state, observable, observed object, and published. The pieces of data in this data model are source of truth for the information that is displayed by user interfaces. A data in this data model is created at one point and destroyed at another point in time. So there is a lifetime that is associated with data. So this lifetime could be a process long lifetime, or it can be more than that. By process lifetime, we mean that the data is not retained after the application is restarted, or if the application is killed and when the application restarts, the data will not be there any longer. It will be re-initialized or re-instantiated. And if the lifetime is extended, it will be retained. For example, app storage and scene storage is something that is used for extended lifetime. But state object, and constants are retained only during the process, only when the application session is alive. Each pixel on the phone screen is defined by a view. Different views are composed in a view hierarchy. The diagram here represents blue, green, and magenta views and how they are connected together in a view hierarchy and how they are being displayed on the screen of a phone. And also it represents how a data model is connected and used by this view hierarchy. The source of truth that is used by a view can be defined inside the view itself, or it can be passed from outside into this view. If the data is defined inside the view, add state is leveraged. If data is passed from outside into this view, binding and environment are something that are used. Let's look into these details in action now by looking and working on a program. Let's create fruit basket using our SwiftUI framework. We will create two new groups, views and models. In the models, we will create fruit as our file, which represent the fruit data. We don't need foundation, so we'll remove it. It's going to have two enums. One is fruit type and the other one is fruit color. By fruit type, we mean something like apple or avocado or pineapple. Fruit color could be red, green or yellow. We are going to define fruit as our class, and this will comply to the protocol of identifiable so that we can index it into the array. It will have its name, color, and is selected. Is selected is something that we'll use to indicate that if it is selected in the basket or not. We will give fruit an initializer which will take all the three parameters with the default arguments, and it will assign these passed in values to those values of the object. We will also define str which will return string representation of the fruit type, and will do the same for fruit color as well. We will give an extension to fruit and provide sample basket as the data which can be leveraged in our previews and demonstrating the use cases. Now we will start building files in our views. We'll create three files. One is fruit basket, one is select fruits, and one is selected fruits. Fruit basket will show the two other views as their sub of child view. We will use add state property wrapper in our fruit basket and make it private. Since we are defining the state as a local source of truth here, we need to initialize it. During initialization, we will give it the initial value, and we are making it private so that the member-wise initializer of SwiftUI will not conflict with the storage management that SwiftUI provides for state variable. We will start defining the body. It will have select fruits as the first child and the selected fruits as the second child. For better differentiation, we will use divider and give it a frame, a color, and a width. Selected fruits will have fruits defined as its variable, and this is to be supplied from outside into this view. We will iterate over all the fruits which are passed in into the input array and display them under this V stack, one below the other. We are going to use color to indicate how the state variable is selected and how it is reflected. When it is changed, how it is reflected into the other views. In the select fruits view, we will use binding. The parent view, which is fruit basket, will pass the projected value of its state into this view as the binding. So this is the writable handle which we can use to update the variable, and that update, that change will be reflected in the parent view as well. Select fruits, we will give the option to user to change the is selected attribute of the data. This change in is selected will trigger the other views which are depending upon it or reading it to update and re-render themselves. This is our fruit basket view, and as we see, the first child is select fruits and the next child is selected fruits. In the select fruits, there are toggle buttons which we are using to change is selected attribute of fruit, and once that is changed, the corresponding change will be reflected in the selected fruits view. So as one child view is updating the object, the change will be reflected in the other child view, which is selected fruits. Let's see this in action. We will toggle avocado, and it has been underlined with its color, which is green. And also the other child view has been and has been given a rectangle, has been colored green. And also the other child view is updating itself by coloring the avocado fruit as green. We will change apple, and since the last apple is green, it will update its change. It will update its color. Let's check with pineapple, and as we see, it is changed to yellow in both, and especially the second child. Apple, we are turning it back, and it's going back, it's losing its green color properly in both the views. Let's see the first apple, which is of the red color, and here it changes the color. So we saw here the usage of state binding, and also the data when it is passed from outside into the view.